Hello, just got a quick one for you today because I'm about to be tied up for a couple of days with a visiting geological society. But every now and then you get an incremental increase in our knowledge that is pushing back certain things further and further. And this is a story that you already know about. So, for those who've been watching the sponge videos, you'll have seen the video on the Llanfallteg Biota hexactinellids, and particularly the family Rosselidae. Now, this is something that we discovered in the latest Ordovician of China, a modern family, quite a distinctive family of deep-sea glass sponges, appearing at 444 million years, which is ridiculously early, and about 300 million years before they should have been there. So, it's quite impressively early. And since then, we've been wondering how far back they go. And the answer is even further. So we've had one or two examples of things that are definitely Rossellid-like in the Castle Bank biota, which is late Middle Ordovician. And then we had a visit from an old then colleague of ours, Ked Connolly, who is the discoverer and main collector of the Llanfallteg Biota in South Wales. This is something I'm going to be shortly doing an entire video on because it deserves it. It's a Conservat Lagerstätte, a site of exceptional fossil preservation from earlier in the Middle Ordovician. It's in South Wales. It's a very difficult site to work. It's been done for 25 years, 30 years by Ked, and he's collected an extraordinary number of things in that time, including some amazing fossils. But there are some sponges there. They're not very common. They're not particularly diverse or abundant. But I just wanted to show you one of the things that Ked has collected recently. And yeah, I certainly wasn't expecting this. Although maybe I should have been. Here it is. Ked uses white paint to mark where the fossils are, and you can see there's this dark sort of splodgy bit in here, slightly rusty, which is the fossil itself. It's not particularly weathered, it's not really oxidized yet, which is why it's showing up as quite a, well, why it's not showing up particularly as a very clear fossil. But let's have a look down the microscope because this is going to be worth it. So the whole thing is just over a centimetre long, and if we look along the whole length of it, we've got a bit of an outline. It's a bit ragged at the edges. It's obviously been damaged where the rock has broken there, but you can see there are very clearly the spicules preserved, which is rather nice. And when you're looking at the form of the spicules, it gets more interesting. But to start with, you've got this sort of basic pattern of a sort of diverging array of them. So you've got almost longitudinal sort of oblique bits in the middle crossing each other, which suggests you've got spicules sort of bending outwards. It's difficult to say for certain which way up this was. I mean, given that it's elongate in that direction, it was probably either the top was at the top of the specimen as it is now, or at the bottom. And given that this seems to be a fairly narrow sort of end without an obvious osculum, a big hole at the top, I'm thinking this is probably the base. But it's actually quite difficult to be certain from that. And then the dominant spicules here are these oblique longitudinal ones sort of projecting out at various angles. Now, the really interesting bit is when you get to looking at these ones in side view at the edge, because hopefully you can already see that there are quite a lot of spicules here that are kind of T-shaped, in this angle at least. So what we have are spicules that are projecting out from the surface and end in a selection of rays going out sideways. So we're seeing two in this plane. You can see another one, that dark hole in the centre there, going into the rock, and there would have been another one coming out of it at 90 degrees. And that would be on the counterpart if we had that, which sadly we don't. But we've got this, and that is what you call a pentactin. It has 5 rays, one long one leading into the body, And you can see these are all, the long ones are sort of bending inwards. And then you have shorter ones sticking out sideways in all directions, but you don't have the distal ray, the one point directly outwards. And so that is what you call a pentactin, as I say. But more than that, these are sort of irregularly arrayed, and they're clearly extending beyond the body wall. So the body wall you can see is marked by this sort of orangish iron oxide stain, which is quite common for Llanfallteg, where you have a bit of pyritization going on. Well, actually quite a lot. And then these spicules projecting out from it are extending beyond the body wall margin. And a large number of these, at least, well, quite a few of them, and many of them you can't tell because they're not well enough preserved, but quite a few of them are pentactins. And that makes them hypodermal pentactin prostalia, which is just basically a fancy way of saying that they are five-thread spicules that stick out from the sponge with the cross, the four of them extended beyond the body wall of the sponge. And they come from a layer called the hypodermal skeleton, but have been extruded. Now, there's only one group of sponges that does that, and that is the family Rossellidae. It's one of the key features that allow us to at least tentatively recognize them based on that alone, because nothing else has evolved to do that as far as we're aware. There are one or two peculiarities and things that we think possibly have evolved a similar habit at a different time, but they either haven't been fully described or they are plausibly stem group Rossellids. So it's difficult to know exactly what those are telling us and whether it is actually possible that this evolved in a different lineage as well as the Rossellids. So ideally you want other features that tell you that it is one of the Rossellidae as well. And that's where this gets difficult, because the internal skeleton here is actually very difficult to see. If we focus in on this iron oxide bit, the orange stained area, now you can see that there are spicules in here as well. I've put in the cross polarizer. That's helping to bring them out a little bit. You've got these dark spicules, the voids, but then there are also these orange spicules which are iron oxide replaced, well, actually they're probably just pyrite still, unweathered. And those are probably forming the body wall, where you have different preservation because the spicules were embedded in soft tissue. And the pyrite is the sort of thing that you get developing where there's soft tissue decay, because you get sulfate-reducing bacteria that generate sulfides that react with iron that give you pyrite crystals. It's a well-known process of soft tissue preservation, and it also very commonly replaces the spicules inside sponges. So I think those orange-stained ones probably are part of the body wall, the interior of the sponge, but there's not enough there to obviously say what's going on. And it seems to be a fairly dense sort of skeleton. If this was truly a Rossellid, at least a modern crown group Rossellid, what I would be hoping to see would be a series of little bundles of monaxons. That was one of their key characters. Not all of them have it, though, and you wouldn't expect it to be there in the ancestors of Rossellids. So I'm looking for that in here. I can see some very fine spicules, and maybe some of those are aligned, possibly in bundles. And then you've got these big black ones superimposed on it, where you have voids where the spicules dissolved after they were sticking out. But in this case, it is very, very hard to say exactly what we're looking at there. This is one of those ones where it's going to take quite a long time staring down the microscope with both eyepieces and getting images of the extra details, and also looking at other specimens, because we do have more than one specimen. Ked's been really productive and he's found one or two others. So I can show you another one. Just put that to one side. This is one that is less well preserved. Or it's, at least it's less complete. But you see again the general sort of elongate, tall form of this thing. Um, some parts of this are really quite poorly preserved, but you can see a few of these big black spicules in there. Possibly one or two of those are postalial pentactins, but they're not really preserved in the right plane, so you can't really tell for sure. And then you go to this end, and you see lots and lots of tiny spicules. And you zoom into these, and you can see once more they have little axial crosses which are projecting beyond the body margin and have very short lateral rays, but those things are projecting from the surface. So they are once again prostalial pentactins. So this again is another sponge which looks to be quite a different thing. It has very different proportions of the different scales, sizes of spicules. It's got a much denser skeleton. The internal part, the interior here, might be more easy to work with. There might be more information here. But it's going to be difficult even then. It's a very dense skeleton. But it looks like this is a projecting array of, once more, these hypodermal pentactin prostalia, which should be diagnostic for the Rosselidae. Not bad, eh? So we then seem to have, apparently, two species of things which have a diagnostic feature, at least, of an extant family, which is of particular interest. Because, as I said at the beginning, these things, until recently, had no fossil record before about the Cretaceous, and then they turned up in the latest Ordovician. And not just one or two, but lots of them, including things that look very, very similar to ones that we have today. Now, the Llanfallteg Biota was basically an outlier. It was the sort of fauna that you don't expect to find, and it was just a unique data point with nothing for the next 300 million years. And then there's the odd one or two examples of sponges that look like they should be Rosselids turning up elsewhere as well. And so one thing we've been really, really hoping to find is clear examples of Rosselids that go back even further. Now, we have a couple from Castlebank, probably more than a couple by now, actually, and those are things that we're working on at the moment. But this is even older than Castlebank. And the strange thing about Castlebank is that it's a relatively shallow water assemblage. We think between 50 and 100 meters water depth, which by hexactinellid standards, glass sponges, is extremely shallow. Today, they are mostly 200 meters plus, and many of them are on the continental slope and abyssal plain. They're really, really deep water things. So that was always a bit of an anomaly. And the Castlebank ones are, again, slightly difficult to work with. Similar preservation to Llanfallteg, actually. But it's very difficult to say whether they are related closely to the living genera, for example. Now, these ones from Llanfallteg, if anything, are slightly more persuasive. There is better preservation of the prosalial spicules. There's better preservation of some of the detail of the skeleton. There's less soft tissue getting in the way, basically. And Castlebank is really good for a lot of things, but sponge taxonomy is a bit of a pain. It normally has all of the really diagnostic features of the skeleton obscured by a mass of carbon where the soft tissue is. It's not great. But here, we do actually have the skeleton quite clearly preserved and really definitive prostalial pentactins. So that is a very good sign. The other interesting thing is that Llanfallteg is deep water. How deep is uncertain, but it was further offshore. This was down in the basin with turbidity type flows. There's bits of volcanic ash coming in as well. It's a relatively deep water assemblage, and the fossil community there is mixed between shallow and deep. This is something I'll go into in another time when I show you the whole fauna and what's there. But you have this sort of downslope transport from shallower water into deep water, but also deep water things that were living there. And the sponges in general seem to have been mostly deeper water things. There aren't that many of them either, and this is something new. So it looks like we have deep water Rossellid-like hexactinellids. This is all quite preliminary at the moment, and I haven't done the detailed work on the taxonomy or anything like that. But if we do indeed have deep water Rossellids in the early part of the Middle Ordovician, this is now pushing the boundary for their origin back even further than we thought. So we have this time scale that is now increasingly being constrained to a narrow window when these things could have evolved. And we know that we don't see anything like a modern hexactinellid until the first traces of things that are getting towards it but aren't there yet are really Middle Cambrian. And there's a new paper I haven't got hold of yet. I've asked for a copy from the authors, but no response yet, suggesting there's something similar from the early Cambrian, but I don't know what that looks like yet. But there are features of things that are looking like hexactinellid, with a complex body wall, multiple skeletal layers, and a highly structured organization of them, from at least the Middle Cambrian. But we start seeing things that are definitively modern hexactinellids, as in crown group hexactinellids, members of the living class, rather than the ancestors of them. Well, we have spicules around the base of the Ordovician, isolated spicules that are diagnostic of a subgroup, a major subgroup, but a subgroup of that class. So those must be from the crown group. And then by the end of the Ordovician, we have things that look like modern genera of the Rossellidae. And so having something which looks like the modern Rossellid family in the early Middle Ordovician, it's narrowing that window. What I really want to know is when the crown group of the hexactinellids originated, and then when they had diversified into the modern families. So all we can tell here is that it happened by the early part of the Middle Ordovician, and we don't have any evidence for the crown group of Hexactinellida before the base of the Ordovician. So that's starting to really narrow that window quite well. Of course, it may be that there are much earlier ones in the Cambrian which we haven't found yet. We do have things like the Nutitang and Hetang formations, which are really important early Cambrian faunas from China. And those have deep water preservation of diverse sponges, and there's no sign of these. So that is good evidence, I think, that at that time there weren't modern type hexactinellids. So probably late Cambrian going into the earliest Ordovician is when the crown group is likely to have originated. But we don't know for sure, and it's going to take a lot more work. But this is what a single little specimen donated by a wonderful amateur collector can do in terms of improving our knowledge. It's really changing the playing field, really, for what the timing for when these things existed, when they originated, when the entire deep ocean community of hexactinellids evolved, how that idea would change our views of how deep sea communities themselves evolved. Because when you have sponges there, that changes an awful lot. The way they capture food particles out of the water, package it into a larger bundle, which can then be food for scavengers. The way their skeletons can collapse and then form the basis of other organisms that can attach to them that need a hard surface. Once you have deep sea sponges, lots of other things can start colonizing the deep as well, when they couldn't before. So it's important. Anyway, I did promise you this would be a short one, and I will leave it there then, because it is a short one, and I now have to go and do other things. But I'll be back early next week with something else. And yeah, just goes to show how much more there is left to find, even in a place where someone has been diligently collecting for about 30 odd years. Well done, Ked. See you again soon.